Yes, can I do it? And I will bring in one more. Whenever we are dealing with this type of triangle, and we had something like 1 unit here, 1 unit here, that becomes square root 2. You understand that? For example, if I try to find a cos of 45, which is exactly the same as finding the sine of 45, which is exactly the same as finding 1 over root 2. So I'm going to add that one here. The cos of 45 degrees is equal to 1 over root 2. Cos of 45 degrees is exactly the same as 45 degrees, which also gives you the same. Is it fine? Alright, so I've separated them for you. They want us to find AB. This triangle might look a little bit messy. Take this one is 8. So to find this distance, go to this angle. This is going to be opposite over there. The sine of 30 degrees is a half. The sine of 30 degrees is a half. So you can say for yourselves, okay, sine of 30, which is a half, should equal to whatever my AB is that I'm supposed to calculate upon 8. AB upon 8. Play around there, and you find that if this is a half, 1 over 2, then AB should be what? 4. Or you can cross multiply and still work it out, right? Do you understand? That takes care of you. Now you go back and you put in your value. See, that's why I'm working on one gigantic shape would be a little bit tricky. Now you come back here to AD. Now they want us to find AD. Now let's write what we have. We have got 4 here. So this is also 4. We want us to find this. Now remember what I said. When you look at this triangle here, the hypotenuse is square root 2. So that is going to be exactly the same answer. Here, we're going to have the same answer, but now with a factor of 4. But let me show you how you calculate it. So you come here, you say, wait a minute, from what I have here, if I want to find the value of AD, you say, so we're doing AD, right? Let me just separate it nicely. So now we are doing AD. So you say AD squared equals to 4 squared plus 4 squared. Remember, I'm supposed to get that as an answer. Because when the units are 1, it's square root 1. It's always that factor of whatever the sides are. So 4 squared is 16 plus 16, which actually is the same as 2. Or let me write 16 times 2. Right? We have to take root because we are looking for the distance. If you look at what you have left, AD equals root of 16 times the root of 2. Therefore, AD is equal to 4 root of 2. Does that make sense to you? Now you can go ahead and you can put the value of AD in there if you want to. But it's a very important fact that you deal with. If you have an isosceles right-angled triangle, whatever this distance, the hypotenuse will be that distance times root 2. Always. Otherwise, use Pythagoras and find it. Good. Now, there's a third one. They want us to find AB. So we are now looking for, is it AB or BC? BC. I bet. So we are supposed to find BC. We can actually calculate BC. That's 8, that's 4, but I don't want you to use Pythagoras. I want you to use that 60. The reason I want you to use that 60 is the opposite, which means we're going to use something opposite that 60 divided by hypotenuse. Or you can use the opposite divided by the adjacent. So it's totally up to you whether you want to use the tangent ratio or whether you want to use the sine ratio. What is the sine of 60? When you come back here, the sine of 60 is root 3 over 2. Can't run away from that root, it will always be there, even if you use the tangent. So, sine of 60, which is equal to root 3 over 2, should equal to BC upon what? Upon A. So, BC upon A. So now we're here. But you don't need to do that. Ask yourselves, 2 times what gives you 8? There you go. Whatever you do on top, you do under. Therefore, the answer is nothing but 4 root 3. You get it? Stop the tape! Now, while she is stopping the tape,